Okay, so I just wanted to go through a walkthrough of the new pipe manager, as it's called. We did some created a multi-stage pipeline system for the IEEE 754 FPU, only to find that it resulted in code that was unreadable. Here is the multiplier code, alright, which is pretty clear. You get two operands, and then you do some special cases. And you normalize, you denormalize the answers to A and B, and you normalize A, normalize B, multiply them together, produce a product. There's stuff in normalizer bits and things, and that bit there, the sticky bit is based on the bottom bits of the product, and then you normalize the answer. Stage 1 and stage 2, you round it, you make some corrections, you pack it into the Z, and you output it, and you're done. Right? It's nice and obvious and sequential, right? Yeah. 36. Here's the version for the adder. So you have to open this one file, and then you have to then go, well, there's a pipeline stage 1, 2 and 3, and where's the code? It's like you have to open up this one, and then that one, whoops, 36, 30, no, 37, yeah, 37, 7. Then you finally get to the actual elaboration, and I'm going because I can't actually find it. Okay, so that's the add zero stuff. Right, okay, here we go. Yes. So depending on what the sign is, you do the total is an add or a subtract of A from B or subtract of B from A. Right? But we'd like that code to be in a sequential form here. Okay? Right? So Hibbs, not Jobs. Touch typing gone wrong. Right, so where are we? Pipeline example %29. So here's the first attempt by using some introspection from PyRTL, which looked really good. Technique to use, and basically what it does is it overrides __ getAttr and setAttr, so that on first occurrence it actually in the function name stage 0 blah 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 whatever it is in sequential order, it will override those and put this number 2, 1 or 0 into the name and automatically create variables which go to things. So it does the m.d.sync or m.d.com in the case of a module automatically for you behind the scenes. So it's kind of neat in that in two regards, that one of the things of Namigen is that you have to do this m.d.com plus equals something.eq, and there's one there. So no, not very nice. Much more obvious to have things like, x equals x plus 5, not x.eq brackets x plus 5. So that sort of convenience is there. Now, to do objects, we then had to do a proxy system. Where you set up the thing, because if you flatten all of the signals, it's kind of a pain in the neck. The whole point of Python is to have object-oriented design. You don't want to be passing around lists of signals when a object will do. That's what Python's for. So here we go. Here's an object proxy, and in the object proxy you have to pass in the module NumiGen module, you can set up a signal and assign it to the thing, and then use it in the pipeline stages. So here, what this will do is it will do a walk of the properties of Object Proxy, looking for things that are recursively either object proxies or signals, and will call the EQ function that was created earlier specifically for this purpose, to assign everything in this side into there behind the scenes. And we can see that here. There we go. MWD.sync plus equals EQ brackets new pipe register comma value, where the value is the right hand side and the new pipe reg is the left hand side. And this is overloaded in underscore set address, an overload of set address. So you can see here that it's creating a new pipe reg, which is passed to this the new object proxy or signal, depending on whether the events. Obviously, we do want to extend this at some point to cope with records and anything else that could be assigned to arrays, etc., etc. But for now, just keeping it to object proxy and to signal. And amazingly, it actually works. You can set up a local variable inside here, and then assign it to the thing, and it will be given a new pipe reg name, so that the code that's generated will be pipe reg underscore 2 to 3, and pipe reg under 3 to 4, pipe reg underscore, and then the actual name. So as you can see, you can just put in stages in here, absolutely no need to explicitly put the names of the registers in. Now reg underscore 2 underscore 3 equal above, etc., etc. Nonsense. Just all that's handled for you. Now what I wanted to do was to take this a stage further and to use the buffered pipeline and unbuffered pipeline stages by isolating the above stages. You see these stages here, all of these are done in the one module context, so there's no separation, no isolation between them. And if there's any blocking characteristics required, you can't do it. Okay, so if this generates a pipeline that is continuous and has absolutely no blocking properties whatsoever. I wanted to add that capability. So to do that, it requires a little bit more sophistication, where the variables, instead of going into a global scope, are captured in what are called a stage class, and I've used a context manager to do that. Now here we have here's the context manager, def stage, and it returns a pipeline stage object. This is your voodoo magic for yielding the variables here, which come out here, right? And you do a finally, and you quit after that. To clean up any resources. We don't need to do any here. And there we go. So now what we do is we get all the input and output specifications for this stage, all the variables that were as inputs, exactly as we've previously done stored in that dictionary by here it is. Where are you? Where's the simple pipeline manager? Okay, yes. So the current stage number is included in here. So when you do a get attr, you use the current stage, but when you do a set attr, you store it in the next stage and pick that up on the next function. However, in this case, what it does is a similar thing. It's stored in the set attr things from the pipeline stage are stored in underscore next stage, and the current ones, when you get after things, are stored in something under the name in the dictionary here. So let's have a look at pipeline stage, which is above here. So it passes in the name. There we go. We have a pipeline register map, which is a dictionary. It could have just had a previous and next underscore previous map and underscore current map, pipeline register map, and underscore next pipeline map. It wouldn't have made any difference, to be honest. Now, where it goes all horribly wrong, amazingly, as long as you don't use object proxies, this actually works. Now, where it all goes horribly wrong is in the recursive application of this to accumulate the assignments and the variables that are assigned to, here you can see pipe reg underscore first underscore n. First is the name of the stage that we gave here. You can see that there. So it creates something which goes, from one stage to the next, no problem, right? So first, second, this is there. So that's its input, and you can see it's going from this PV is the activation. It's the when it says you're ready and valid. Previous and valid signals are active, so here you can do a clock sync, no problem. All right. Okay. So the pipe reg first n is going in. It's going round a loop there, which is your synchronization thing, your clock synchronization thing, and there you get the stuff added, and boom, 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 ta-da! There we go. All right. Now you can see couple of problems here. The first is there's actually two copies of pipe reg first underscore n. This is not correct. The second is that there is a B here which comes in. That's the correct input, but unfortunately this here must be linked to that, just as that there should be equal to that. Right. So let's just a quick check of the code again. Let's go back to the code here. So yep, here we go. Which one of these is it? First contributes the first n, from n from stage named first goes into C through to value C, and first plus B is added, and then added thing ends up in D. Yeah. Doesn't look quite right, does it? B plus n plus 5. Oh yeah, there we go. B plus n plus 5 goes into D. Yes. Yeah. Yeah, that looks great. So you can see there's that minor fly in the ointment that is not quite connected up. C is being created as an independent variable. See, B goes into there, and that's all right. Yeah, that first $n is definitely not okay. So little things like this. I think actually B is not a part of the output, so I think we're okay. No, it's not. Yeah, B there. Yeah, that B needs to be connected to this B here, because there it is the input part, and that bit, because it's part of the recursive aspect of this thing. I'm really completely lost and could really do with some help trying to track this down. So that's the primary reason for doing this video. So thank you very much. If you'd be able to help, it would be really appreciated.